Okay, so now this video assumes that you have installed all the software. Once again, it should be done for you, but it also assumes that you've plugged the proto board or the proto snap board up to your computer. So this is the proto snap board here, and going to go through quickly the parts here. So there's some basic parts. As you can see, they call it a proto snap because they make it easy for you to prototype stuff, and this is why we use it. We can do some input stuff and some output stuff without having to hook up wires to the Arduino, so it's good training, good introduction, especially for middle school students. The combination with the RG block to minimize typing is also good, and then to introduce them and walk them into the true Arduino programming environment. So we feel like this is a good segue. And so the proto snap board consists of several parts. This part here is the part that this is the USB wire that should be plugged into your computer, and this is the block that basically translates it's the FTDI chip that translates communications from your computer to the board. Over here is the processor. Now your board might not have these black strips on it. These are headers that got put in for some purpose for this particular board, so it may not have these strips, but that's okay. And then I have this board attached to a proto board down here just to hold it down for purposes of this video, but your board may just be this red piece, which it should be, and that's fine. This piece here is the processor. That's the same processor that's inside of the Arduino. It sits there, so that's the brains, and that's what we're actually programming. There are a couple of lights and a button here. These lights indicate power being on, and also indicate communication when the proper communication is actually happening to this chip here. When that is happening, this light will blink. This light over here is an LED light that's hooked up to pin 13, and so we're actually going to use this in this video to show our program, and so that's sort of the output right there. So that's outputting a green LED. This is a reset button. Shouldn't have to use it, but if you need to, there it is. And other parts of this, down here you have a button that's used for the user to interact, so we can program things to happen when this button is pushed. We have a light sensor, so by putting your hand or something over that, making it darker, you can read various light intensities. So that's a source of input. So these are the two inputs that we have here. We have an RGB, red, green, blue LED light emitting diode here, and so this one you can actually change the colors, and we'll do some things with that. This is a buzzer, speaker buzzer. It allows us to output sound, and so in this area over here is if we were hooking other things up, like motors or other sensors up to the board, we put them over here, but we're not going to do that. Once again, your input is here, your two inputs are here, and then you have basically three outputs: the RGB LED, the buzzer or speaker, and then the LED I discussed up here that's connected to pin 13. So that's a basic tour of the proto snap. When you use this with students, tell them very sternly not to unsnap. These little pieces can be broken apart. That's what the snap part is, but we're not going to do that. So tell them to handle this with some care and to not break it apart. So that's the proto snap in general. And so now we're going to move back over here to the computer, and this is as we had in the last video, this is going to be our programming environment. On the right we have your basic Arduino programming environment, and on the left we have the RG block, which is going to allow us to do some drag and drop, and it's going to actually, in a sort of cool kind of way, translate the code, the block code, we do over here, and translate that into code, actual Arduino code over here, and then it's going to download that to the proto snap board. So now the project we're going to be doing here is a modification of the sort of basic getting started project, which is called blink. We're actually going to get the LED to blink, and if you notice, this LED is actually blinking in a predetermined pattern. I've already programmed this. This LED is blinking out the Morse code SOS, and so to give you an idea of what we're going to actually be doing and where we're going, so here here, for those of you who don't know Morse code, this is the Morse code for S, this is the Morse code for the letter O, and so SOS is this. And if you look here and notice the light here, it is blinking out SOS. And so that's what we're going to be doing in this tutorial, and this is what you'll be doing week 1 with the middle school students. You can take this a little bit further once they get a whole grasp this concept. It's always good, especially with middle school kids, to have them personalize stuff. And so you know, we'll give you a worksheet for the entire Morse code alphabet, and then what you could do is have students code their initials. And so that will be the step beyond the SOS, but I'm going to show you how to get them to SOS, and doing that will allow them the basics to move forward. And so we'll put this over here, and that'll be provided for you in a worksheet. So let's get started here. Every Arduino program exists with 2 parts. And I guess let me back up. You'll sort of learn how to use this programming environment as I go through it. So I'm not going to cover a lot of it, but basically you have buttons over here that are, if I like to think of them as drawers with blocks in them, and so you click on these various buttons and get blocks that help you write code here. And so that's what I'll be doing. I'm going to be programming on the fly, so if I make a few mistakes, please don't judge me on that. So anyhow, I'm going to go here. You always start off with this block here. A basic Arduino program has a setup and a loop. And here's what's sort of cool. If I hit this upload to Arduino, this will actually upload and we'll see the code over here. But I'm going to do a program before that actually happens. Okay, so I'm not going to put anything in the setup in this particular part. What I'm going to show is a progression. I'm going to do this the hard, ugly way, and then I'm going to do it a little bit easier way, and then a little bit easier way, and a little bit easier way. And the idea is to show this progression so the students will gain this knowledge and this concept of a couple of programming concepts. So let me set up my environment. I'm going to make this window a little bit shorter, narrower, and I'm going to make this a little bit wider. Okay, so I got my program here. First thing I'm going to do is just make the light blink. And so to do that, I bring up my program, I come here and I do set digital pin. So on the RG block, things are connected to pins. It so happens that, as I said before, the blinking green LED is set to pin 13. If I turn that high, that's turning the pin on. So I set digital pin 13 to high, will turn it on. Then I'm going to wait for a period of time, and so I'm going to go here to control, and I believe the block is down here somewhere. I'm going to delay, and we're going to do it in milliseconds. I'm going to delay, let's just say 1,000 milliseconds, and then I'm going to go here to pins again, and I'm going to set digital pin 13 low, and then I'm going to once again wait 1,000 seconds. Now, because this is embedded programming and you're programming a chip that sort of lives, this proto snap board here lives in the real world. It's not like a program that lives, it's not like a program that lives on a computer. It actually lives on this chip and is interacting with the real world type of deal. It sits there, and the program that you put on the chip runs continuously in this loop. And so what's going to happen when we execute this program is it's going to set digital pin 13 to high. It's going to wait 1,000 milliseconds. Then it's going to set digital pin 13 to low. So it's going to turn it off, and then it's going to wait 1,000 milliseconds. And then it's going to loop back up here to the top and repeat. So it's going to do it over and over and over again until you stop it, or you run out of power, or you turn the power off. So that's the sort of difference in if you've never done embedded programming before. Okay, so now we're going to make this happen. We hit upload to Arduino, and you see over here what has happened is the program is here. Also down here, if you look, it says it's compiling the sketch. And so what's happening is it's actually converting this code into ones and zeros. A program in this environment is called a sketch. So it's converting this to ones and zeros. It's uploading it now to the board. If you saw, the lights here are blinking, and you can rewind the video and check it out. But you saw a whole bunch of lights here blinking as the communication was happening. And then it says over here, done uploading. And so now it's ready to go. And if you don't see any, you don't want to see any orange letters or anything down here, everything was successful. It's cool. Okay. So if you look over here, now our light is on for a second, off for a second, on for a second, off for a second. And that's what we programmed it to do. Right. Now I'd like to go back and look at the translation here. So this is the drag and drop environment, the program that got converted over here to the Arduino program. And so if you can see the conversion, there's two parts to every Arduino program. Over here in the drag and drop, you see there's a setup part, and we didn't put anything in the setup part. And then there's a loop part, and that's where we put our function, and that's the code that iterates over and over again. So the setup code runs once upon starting the program, and then the loop keeps running over and over again. So over here in the setup function, you see it automatically put in pin mode 13 output. It's smart enough to know that we set pin mode 13 over here, so we'll be using it as an output. And what it did was put that line of code, that instruction, inside of the void setup part of the program or the sketch. Then there's the loop part that it actually put the code digital write 13 high, delay for 1,000, digital write 13 low, delay for 1,000. So this is the actual Arduino code that gets interpreted out of doing this drag and drop environment over here. And so you can see how this is sort of a training wheel type of deal that will do some programs in the drag and drop. Students will begin to understand, and then we'll just start coding over here in the Arduino piece. Okay? All right, so that gets our light blinking. And so in some senses, that's really the core. We've done sort of what we need to do, or figured out what we need to do to actually do the Morse code, but now we need to implement it properly. And so let's begin by doing that. We're going to start off with just doing the letter S. And if you recall here, the Morse code letter S is dot, dot, dot. So the way we're going to implement that dot, dot, dot is we're going to say that a dot, at least for the purposes right now, and this will change as we modify, that a dot is on for a second, and then this space between the dot here is off for a second. It will go on for a second, off for a second, on for a second, and we'll go back off for a second, and then we should see the light going on for a second, off for a second. Well, lo and behold, we already have that, right? This is doing the letter S. So we need some kind of thing that's going to separate the letters. So we need a sort of a longer delay for separating the letters. And what we'll do is after this S will be, let's go off for 3 seconds, and then the whole thing will repeat. Okay, so let me get rid of this. And so here we go. So this is a dot. So this would be dot here. This whole thing is a dot. It's on for a second, off for a second. So that's the dot, and then the space. All right. So let me show you sort of a feature of ArduBlock. So I'm going to do this. Come here, right click, and hit add comment. Right. And I'm going to call this dot just so I can keep up with stuff. All right. And I can, I can make this smaller. Whatever. So that's those are my comment. That's my comment there. Drag this over here, and so now I can come here and hit clone. So that's one dot. Right click again, clone. 2 dots. Right click again, clone. That's 3 dots. And then what I also want is sort of a 3-second delay between, so when it does this dot dash dot dash dot dash, I want another 3-second delay to separate the letters of this particular SOS. So what I'm going to do is come here to millisecond, and I'm going to come here click on the number and put 3000 in there instead. Right, and then I'll do this and hit add comment. Oops. I'm going to call this space between letters. Okay. So that's my comment there. And I'm just making stuff look a little better. You don't have to do all that, but so there we go. And then I'll come here, right click, clone that. If you scroll down the screen, whatever you clone, it's sort of a pain here, and you'll see it when we get longer code. But it always shows up in the upper left-hand corner, so sometimes you got to scroll up and get it. And so I'm going to come down here, put that in there, and that'll be the space between letters. So this will go dot, dot, dot. So it'll be on, off, on, off, on, off, and then it's going to wait for 3 seconds and then go back up and do on, off. So this will repeatedly do the Morse code letter S. And so I click upload to Arduino, and you notice these blocks over here don't get translated. They're just things that I'm using. Only things inside of the loop or the setup get translated. And so you see all this code now has been translated over here. Stop the video to convince yourself of that. It's still compiling. Sometimes it goes slowly, sometimes it goes quickly. But you see, so take some time, stop the video, and understand how this gets translated to this over here. And you can go over here and you can see, if you look, it's on, off, on, off, on, off, and then it waits for 3 seconds. And then it starts again, on, off, on, off, on, off, and then waiting for 3 seconds. So we successfully made the Morse code letter S. All right. Now I could go on and define the dash and then put that in here. Now I'm going to do this, and like I said, I'm going to do this the sort of very long way around, and then we'll continue to make it efficient. So let's do a dash. So a dash is like a dot, so I'm just going to clone this, and then I'm going to come in here and add the comment dash. And once again, the comments are just for me to keep track of my code, which is what comments are for. Now, so let's go back over here. If you notice, the O, the dashes, I just say, okay, well, those look like they're 3 times longer than the dot, so we're going to go 3 seconds on, a second off, 3 seconds on, a second off, 3 seconds on. Right? So let's do that. So I'm going to come here, and so we're going to go on. I'm going to change this to 3 seconds on. It will be a second off. Okay. And if we do that, if 3 seconds are separating our dash, then I'm going to come up here. Whoops. I'm going to come up here and put 5 seconds to separate actual letters. So it's just a little bit longer delay. Okay. So now, let's go here, 5 seconds. Okay. So now we're going to put dashes in. So the O in our SOS is dash, dash, dash. So I'm going to clone this. Dash, clone, dash, clone, and now you've got to sort of scroll and use the windows to get this to work. Dash, and then I'm going to, that finishes my O in SOS, and so I'm going to separate that with there, and then I'm going to go back and do dot, dot, dot. Now I could just drag this dot, dot, dot down, but I already have a dot, dot, dot here. So this is the way you can use the environment. Right click, I clone the whole thing. There it is. And then I'm going to come over here and actually edit it. So the dot, dot, dot that goes down to here, which is, this is the word separator. I'm going to take this and trash it. So I take the bottom part, throw it, I put it over here in the area where the drawers are, let go, and that goes away. And so now I'm left with just my dot dot dot, which is my S. So I'm going to put that here, and then I'm going to put the separation between letters again. And yes, this seems ridiculous to scroll all the way down and all this, but once again I said I'm going to modify it. So I have my dot dash, my SOS here, and so now I hit upload to Arduino. You see the code here. Once again, check it out, look at it, interpret it so that you understand it, and the sketch is uploading, and when that finishes we'll actually see it run. So what this program here is SOS dot 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 dash 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 dot dot dot. Okay. Okay, so it looks like it's done uploading down here. All right, and so if we look, let's see what we have. We got dot up, on. Looks like I'm in the middle of the O there, so like dashes. Let's see. There you go. Dot dot dot. This is that 5-second delay between each letter. Dash, dash, dash. And then another 5-second delay between the O and the last S. And then we have dot, dot, dot. Okay, so now you say, well, Cedric, that was long. Can't we make these gaps between them shorter? How do we adjust them and all that, right? So now we talk a little bit about coding, because technically we've completed our task. We've done SOS, right? However, we look here, we have this long code, and the problem is also this code's hard to maintain. So what if I wanted to say, I wanted to shorten it? I said, okay, that's taking too long. I want to do maybe a half a second or a quarter of a second for each dot, and I want to make the distance between each word, the time wait between each word, maybe only a second, right? And I wanted to tweak this. Well, the problem with that is that I would literally have to go into each one of these blocks and change them, right? And that's really, really inefficient. It's a very inefficient way to do things, and so there is an easier way. And so now what we're going to do is we're going to define some variables, and that way we can sort of change them at will. So what I'm going to do is take all of this code here, I'm going to keep it, I'm going to push it all the way to the right. In fact, let me go ahead and hit save and save this. I'm going to save it in my Dropbox folder here. So to keep track of everything that I have to keep track of, I have a pretty extensive folder. Okay, I've done this before, and I have this thing saved as blinkSOS. I'm going to call this this particular one, blinkSOS version 2. Actually, with Arduino files, you're not supposed to be able to have spaces in them, so let me close the spaces in. Alright, so RGBlock files, you can have spaces, but there you go. So it's blinkSOS version 2 here. Okay, so now what I'm going to do is take and move all this code sort of over and out of the way. I'm going to copy it and use it, but I'm going to move it over and out of the way. And I'm going to come here, I'm going to take all of this and move it over here. Okay, so now let's look and let's sort of redefine some things, right? So we go here, we look, I want to actually, instead of having to put numbers like 5,000, 1,000 every time. I actually want to create a place in memory, a variable, and be able to change that when I need to. And so the way you do variables here in this language is, so I'm going to come here and I'm going to, let me do some copy pasting because it makes sense. I'm going to take this and clone this one. Alright. And I'm going to come here and do variables and constants. And I'm going to, let's see. And this is sort of cumbersome if you've done variables before, but it does make sense. I'm going to call it, I'm going to call this one space, since this is the space between letters. And I'm going to give it a value of 5,000. Okay. And now here, instead of defining it as 5,000, I'm going to go here, grab this variable, and actually I probably could have done this without doing this, and I'm going to type in, well, no, that's wrong, that's a numeric variable, I'm sorry. Come here, where are the variables? Oh, integer variable name. I'm going to grab integer variable name, whoops, okay, let's do it down here. And I'm going to set that equal to space. Okay. I'm going to throw away these two here. Alright. So now, what I've effectively done here is now my space delay, and let me go ahead and add another comment here. My space delay is now based on this variable space. So whenever I change this value will change. Okay, now that's convenient. So let's do this again for setting the how long the dot stays high and how long it stays low, or the space between dots, and then how long the dot stays high and the space and the dash stays high and the space between dashes. So we're going to define this in our variable space. Whoops, let me get back over here. Okay, so I'll do this. I do a lot of cloning when I do this. So let's call this one dot space. Oops, wait a minute. Dot on. So this is how long the dot stays on. And I think right now we have that at 1,000 milliseconds. Let's do another one. And there's no space here between dot on. You cannot have a space in variable name, so make sure you don't put a space in there. Dot off. And right now our dot off is 1,000. And then we'll do dash on. And right now that's 3,000. Clone that. And we'll also do dash off and make that 1,000. Okay. So now we've defined those things. And so I'm going to leave this up here just for educational purposes. I'm going to, and for comparison, so that you can begin to think about how you're going to teach our students this. And so I'm going to clone this piece here. And this is going to be, once again, it's a little slow at first, but I'm partly doing this so that you get used to this environment and so that you feel very comfortable when teaching it. Okay, so what I want to do is replace this with a variable name, and I can just clone this one here. I could go to the drawer and get one, but I sort of like to minimize my trips to the drawer. And I'm going to change the name here to dot on. And then I'll clone this one again. Get rid of that. as you can probably assume, I'm going to do the same thing with dash. So add a comment. Now adding comments, once again, is not necessary, but it does help at keeping track of things. And so the computer could care less, but as a human, it does help us out. Okay, so what I want to do here is change this to dash on and change this to dash off. Alright? And so now I'm going to do the same thing I did before. Clone this and do my S, which is dash. Clone this. Excuse me, dot, dot, dot. And then clone the space between the words, or between the letters. There we go. And then now I'm going to do a dash. Yes, this is a little slow, but once again, I want to make sure that you understand and that you're well trained before you go out and do this with the students. So taking the time to go through this step by step. Dash, 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 and then delay. And when you're teaching this to the students, you can put this up on a big screen and have them follow. We can print it out so that you can show them this and explain it. I think we'll do a little bit of both. And then now, instead of doing, I'm just going to clone this like I did last time and go down here to take off. And then this leaves me with a complete S, letter S. And I'm going to put this down here. Okay. All right, now we're going to upload this to the Arduino. And if you look over here, and this is a part about RGBlock that I'm not exactly thrilled with, but it works. It does all RGBlock variables. It starts them with the underscore, capital A, capital B, capital VAR, underscore. This is variable 1, and its name is space. This is variable 2, and its name is dot on, dot off, dash on, dash off. So all of those are there. It starts them as integers, sets them up as integers, and then in the setup, it assigns the values that we assigned over here in the setup. Okay, and then it puts the variable names in here. So now, instead of having a bunch of hard-coded numbers, now they are variables. And so if we want to change these values, we can change the values up here in the Arduino code or over here in the RGBlock code. And if you notice, I'm not going to go through this for the whole time, but if you notice, we're blinking over here, and it's still the same sort of slow pattern that we had before. Okay, so now, if we want to make this go a little faster, instead of having to, as we talked about before, instead of having to, and this was our code from before, instead of having to go through and change each one of these blocks, which is seems to be a rather ridiculous proposition, now I just have to change these blocks here. And so I can come in here and say, okay, well, instead of my dots being on for a whole second, let's make them on for a quarter of a second, so 250 milliseconds. And let's keep it off a half a second. And then let's do dashes 3 times longer, so let's do those for 750 milliseconds. And then once again, between the dashes, that space between the dashes, 500 milliseconds. Okay? And then the space between the words, I can drop that all the way down now to, let's say, 1500 milliseconds, twice as long as the dash. Okay? Now, with those simple changes, I can speed up my code, I can speed up my light, get something a little bit more user friendly. You can see here when we uploaded, the values here changed for our variables, and then we're still compiling the sketch, so we have to wait for it to work. So they're uploading, and so now look, our light's moving a lot faster. So these are our dashes, dash, 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 and then dot, 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 right? And these values still may be a little slow, so you can keep tweaking them, but this is decent enough to so that each letter is clearly articulated. So that's how you change it. Now we can take this even one step further, because since all of these things are sort of based on, at least in my mind, if you look here back at the Morse code, it looks like a dash is 3 times. It looks like the space between here, even with the between the dots and the dashes, the space is about the same as a dot. So if I make a dot 250, I should have probably made this space here. Whoops. Probably should have made these spaces 250. Right? Probably so. And then let me see if I can get that image back. There we go. And then these look about 3 times longer. So over here you see it's about 3 times longer. And so and then the space between the dashes is the same as the space between the dot. So I could probably make this even a little bit cleaner if I do something like this. If I say, okay, everything's based on how long the dot is, or I could say it's based on how long the space between the dots and the dashes are. So just as another step, and I could probably do this even a little bit cleaner, but I could probably say, okay, the distance between words or between letters is 3 times longer than is twice as long as how long the dash is on. Okay, so why don't I do this? And I hope I haven't confused anybody, but let's do this. The dot is off the same length of time that it's on. Okay, so instead of putting 250 here, why don't I just use the variable dot on? So the dot is off just as long as the dot is on. Okay, so this is dot on, dot off equals dot on. Okay, the dash is on 3 times longer than the dot is on. So get rid of this. Come over here to math operations. Get this multiplier here. Put that here, and say that the dash is on. Clone. And then I need a number. No, variables, constants. Come here, grab a number. 3. So 3 times. So the dash is on 3 times longer than the dot is on. Oh, now this makes more sense here. And then the dash is off the same time that the dot is off, which is also the same time that the dash is on. So I really don't need this, but I'm going to go ahead and use it. I'm going to do it this way. Take this out. So the dash is off same time, same length of time again as the dot is on, and then the space is twice as long as the dash. And so I'm going to come back in here, go back to math operations. And so clone this one and come in here and grab a variable constant, get an integer twice as long. Now the only problem with this is if space is going to use dash on in its definition, then it needs to come after dash on has been defined. So I'm going to take this out, and this sort of helps you, show you a little bit of editing, separate there, move this under, and put this back. There we go. So I define dot on as 250, and then dot off is the same length as dot on. Dash on is 3 times longer than dot on. Dash off is the same as dot on, and space is twice as long as dash on. And so everything has been defined before it gets there, and so I won't get a syntax error. Okay, so now all I have to do to change the behavior of this is change this one value. So if I want things to go faster, let's say my dot on is only a tenth of a second, right? And then everything else will change accordingly. So I go now to upload to Arduino. As you can see here in the setup, now dot on is defined as 100. Dash on is the same. Dot off is the same as dot on. Dash on is 3 times dot on. Dash off is the same as dot on, and space is twice of dash on. Okay, and then it is done downloading, and so this should move a little bit faster. So there's the O, that's the S, and that's the L. So S, and then it starts like over S, O, S. Okay, and maybe I should, at the end of the whole word SOS, maybe I should make the delay a little bit longer. And so what I'll do is come over here and I'll put 2 spaces in instead of just 1. So clone that, come back up here, grab this. So at the end of the whole SOS message, so that I can actually distinguish between the last S and the first S once it loops around, I'll double up my delay here. Okay, so I do that, and it loads. You can see it happen down here in this code, and it loads, and it'll show. Okay, all right. So now this is sort of cool. It's a little bit better, and we've taught the students variables. So now we're sort of deep into this now. I mean, we've talked about variables. We've shown math functions. We've shown basic setup. That kind of thing. We've talked about this concept of code reusability is taking these blocks now. But here's the deal. You know, instead of having to drag and drop that whole thing, wouldn't it be nice if I could just make one thing called dot and something called space and something called dash, right? And then this wouldn't be so long, right? And this now introduces the concept of functions. Right? Functions are neat because we can make a function that does dot, and so here's how we do it here. We go to control, and I don't agree with they use an old programming term called subroutine here. They should just use, instead of subroutine, they should just use function, but you know, it's what we have. And so here now I'm going to redo this program once again. Let me move this over here. I'm going to take this out of here, put that there. Now if you allow me a little bit of time here to clean up. Now once again, I'm doing this to help you get ready, to teach. However you and your team decide to teach this is fine. Once again, we can have printouts on this, and so that you will have this as reference. But this is why this year we're taking people through training, so that you can take this and figure out the best way to do this. Okay, so here's our first iteration. We have numbers. Here's our second iteration. We put variable names in there, right? And we've talked about how that's useful. It enables us to change things and maintain our code and modify our code a lot easier. Now we're going to take it another step and create these things called subroutines, which they're functions. So I would call them functions. They're just called subroutines in this particular language. And so I'm going to create a subroutine called space. And that subroutine, what I'm going to do is simply, and I could copy these. I guess I'll copy these for completeness. I'll clone this, and so now I've got a subroutine here. And once again, forgive me, getting So there's a subroutine, we call that space, right? Um, or a function we call space. Get another one here and define my dot. So I'm going to clone this, put those blocks of code in here, and now I can refer to these blocks of code as dot. And then get another one. And I'm going to put my dash in here. And so now I can refer to these blocks of codes as dash. Okay? Now I go back over here and I go to control and I get a subroutine block. And now if I come in here and do dot, right, and I'll clone that, dot, clone that, dot. Now I'm going to do, let's clone that, but what I want to do is put a space in here. Space. Cool. Whoops. That was stuck on me there a minute. Okay. So that's my S, dot, 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 space, right? Clone that. Whoops. So now I want my O, dash, 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 right? So that's my O. And then I want another S. So I'll come here. Let's take that out. Okay. And then I want another space here at the bottom so that I can tell when one SOS ends and the other one begins. Alright, much cleaner code, much more readable, it's maintainable, much cleaner way to do this. And so this is the beauty of functions. And so if I upload this to the Arduino, now we look, and while this is uploading, let's look at the code. Once again, I define my variables up here. I have other variables. These are my functions. It defines my functions as being empty at first. These are my functions, dash, space, and dot. In my setup, it sets up my variables as before. Here's my code, dot, 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 space, dash, 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 space, dot, 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 space, and then another space to separate the words. And then my function space is defined as a delay of the length of the variable ABVAR5 space. My function dot is just what we determined was a dot. And then my function dash is what we determined as dash. Much cleaner code, much easier to maintain. This is the way you do it. And so now you can see the rhyme or the reason behind my my progression here. Okay, and so now if you go over and look, we're still running the same code, but and there's my there's the first S, the O, the second S, and then it loops back around. Okay, so you can see that over here in the video. All right, so now that's clean. Now let's take it one more step. There's one more way we can do this to make it a little bit cleaner, and I'm going to move. I'm going to take the time to move these down. I'm going to create two more functions, if you will. And so this was cool, but I think we can do just a little bit better. So I'm going to leave this over here. So why don't, because we look here, this dot, dot, dot space is an S. This dash, dash, dash space is an O. And this dot, dot, dot space is an S, right? So why don't we just use this whole notion of functions called subroutines here and create subroutines for the letter S, the letter O. And so I do S, and I'm going to, let me duplicate this so that I can have the original there. So when you use this here, break it up. This is an S. So I'll stick that in there. And then likewise, let's not do that. Let's do this. Likewise, I'm going to create a subroutine called O. Don't need the bottom here. Well, I may need that extra space, so let me separate that. That's a duplicate S, so I don't need that because I already have an S. And there's an O. Right? And so now I can come here, and this is cool. If I right-click this and want a reference to this function or subroutine, I do right-click and do create reference, and now I have a reference to the S. So now my message is S, which is complete with the space to separate the letters. And then I do another create reference. Oh, it hasn't. Sometimes this language hesitates to actually, you can see here it's still blinking. It hesitates to actually instantiate stuff, but it works. And then I need another S, create a reference. That's my O, that's my S, and then my space, I'm going to wait here. Right? All right. Yeah, I don't know why this is not. Okay. All right, so now I've even shrunk it even more. I just type in SOS. And now my code is much more intuitive than it was before. I don't even have to know Morse code. And you can see how now students could just make letters and do their initials. And so let's go upload to Arduino. Now you can see what has happened is it's added 2 more functions. Everything else is the same, but it's now added the S function, the O function. It's instantiating them here up as void, and then it comes down here and it says SOS. That's my main loop. And then I have my S function, which is dot 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 space. I have my O function, which is dash 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 space. And then I have my space, dash, and dot functions. Right? And this language is smart enough that they don't have to be necessarily defined. The functions are self-contained, and since they aren't used into the execution part, they don't have to be defined in order. And if you didn't understand that part, don't worry about it. So now everything's working here. So now I have built a much easier environment here. So if I wanted to come back and not just do SOS, but come here and create my initials if I wanted to, I could come here to the Morse code, and we'll have to get you sort of a better printout because this one's a little hard to read. But it's all composed of dots and dashes. Now you see how I can very easily create the letters for my initials or any word that I wanted to do, and then create a reference to each letter and stick it in here, and very easily do my initials, my name, whatever. And like I said, if I were you, I would do that and have the students do that because they really like doing things that are personalized. And so this is the tutorial. Like I say, take pieces of it. The basic notions of this are showing them how to use the environment. We've done a lot. We've shown them how to use the environment. We've set up variables. We have made functions. And so a large part of programming, if they can get these concepts down and take it slowly with them, and they understand this and feel comfortable in this environment, then the other projects that we do and the other tutoring that we do will be a lot easier. So I know this has been a long video, but I think the training is worthwhile. And this is once again just the beginning, and other ones will go a lot faster. So thank you very much for watching, and thank you very much for teaching and going out and changing lives.